Hello students, this is Dr. Dias, and let's practice a little bit how to construct a structure and use the structure, and also how we identify the base structure through the formal chart. So we know that typically the least electronegative element will go to the center, but let's look to the formal charge to understand why it goes under this occurs. Okay, so here with the CO2 we can draw like three possibilities. So let's start with the possibility 1. So carbon will go to the center, and first let's go step by step. So carbon valence electrons first. So we have 4 valence electrons for carbon, and we have 2 oxygens, and we know the valence electrons is 6. So we have 6 times 2, 12, plus 4, 16. So we have 16 electrons to distribute in this bond. So first thing, you draw the skeleton, which is, let's connect all the elements. So here I have C, O, and O. I put this carbon and a center. So now I just use it 2, because we know that 1 dash represents a pair of electrons, right? So 1, 2. So now we use a 4. So we have here still 12 to go. So oxygen will be stable if they have 18 electrons. So we can put 6 over here, and we have 2, so happy, right? So we'll comply with the octet rule, and we can put the other 6 over here. So now I have distributed the 16 electrons, so I have 6 plus 6, 12, 14, 16. However, carbon is not happy. So I can do is use this, and let's share a pair of electrons from both oxygens over here, and the carbon and the oxygen will be happy. Don't forget to raise the electrons over there. So let's count over here. So I have 1, 2, 3, 4, right? 6, 8 electrons for oxygen, so comply with the octet rule. Carbon 2, 4, 6, 8, and oxygen here 2, 4, 6, 8. So now let's go to the formal charts. For formal charts, we calculate using, let me just put over here, valence electrons minus bonding minus non-bonding electrons, right? So let's calculate here the formal chart for each one. Let me just erase it here. And I will just put here the loose structure, okay, and here we're going to put the formal charts. So for this oxygen here, that will be the same for this oxygen over here. We have 6 valence electrons, and we have 1, 2 bonds, and we have 1, 2, 3, 4 electrons non-bonding over here. So it will be 6 minus 2 minus 4, 0. Let's go to carbon over here. With carbon, we have 4 valence electrons, minus 1, 2, 3, 4 bonds, and we have 0 electrons around that. So it will be 0. And this will be the same of this, so we have 0. So this is the value that we have for all elements over here. Formal chart 0. But imagine if you have, okay, instead to put like double bonds in both sides, let's use the first oxygen as the humble one, like the hero. He is not selfish like the right one over here, so he shares 2 pairs of electrons of carbon. And look at this. Let's calculate the formal chart for this one. So we have 6 valence electrons, minus 1, 2, 3 bonds, minus 2 electrons non-bonding here, so it will be plus 1, right? And then we have, because 6 minus 3, 3, minus 2, 1. And we have the carbon over here. So we have 4 valence electrons minus 4 bonds, because we have 1, 2, 3, 4, minus 0. So it will be 0. So now we have plus 1, and we have 0 over here. And this will be 0 because we calculate. No, we didn't calculate. So let's calculate this. Let's see if it will not be 0, because we have 6 valence electrons, and then we have just 1 bond, right? 6 valence electrons, 1 bond, and 6 non-bonding electrons. So it will be minus 1, so negative 1. So just to look at those two, we know this structure is better because the structure of the molecule will be more stable if you have formal charge close to 0. And here we don't have the formal charge close to 0. I have a positive one here, negative one here. Just to look at the summatory of the charges, it's equal plus 1 plus 0 plus minus 1 will be 0. Right? So the summatory of the neutral molecule must be 0. But since we don't have like 0 for all as in the first structure is better than the other one. Okay, so let's see if you put the oxygen over here in the middle. And they're going to have oxygen and carbon and oxygen over here. So let's distribute the electrons around and make everybody happy. So I will do exactly what you did over here. So let's do this. And then we're going to put this over here and this over here. So I have 2, 4, 6, 8. And then carbon needs 2 as well. So 4. Sorry. So let me just erase this because this is not beautiful. Let's put over here. So I have 1, 2, 1, 2. So now I have 2, 4, 6, 8, 10, 12, 14, 16. So everybody has all the electrons needed. So let's count the formal charge. So the first one will be exactly like this one over here. 6 minus 2 bonds minus 4 electrons will be 0. This one over here, I have 6 minus 4 bonds minus 0 electrons. So will be plus 2. This is so biggie, right? Plus 2, this is 0, and this one over here must be minus 2 because the summatory must be 0, right? So this will be 4 minus 2 bonds minus 1, 2, 3, 4. So will be minus 2 as well. So now you can see why you use the less electronegative in the center, and it's easy to construct the structure if you follow the steps. First, draw the skeleton, and then distribute the electrons around. Make everybody comply with the octet rule. Okay, so the best structure over here, we have this one over here. This is the best structure because it has the lowest formal charge. And what about ions? What happens when I have ions? Let's look to C and S minus. Imagine, also here, we could have like a different structure. Could be C and S minus, or could be NCS, or could be, let's not forget the negative sign over here, CSN. See that I'm changing who is in the center? So let's see which structure is better. Remember, the summatory must be equal the charge of the molecule. If it's a neutral, it will be 0. If it's not neutral, it's an ion, need to be exactly the same. The summatory must need to be exactly the same of the charge. So let's go to this one first. So let's use carbon as in the center. Let's get this carbon, and we have sulfur, and we have nitrogen over here. Now let's distribute the electrons around. Okay, I know I didn't count. So we have 4 electrons, and we have how many? So we have 5, right? Nitrogen. And what is the sulfur? The sulfur, so you need to go to your periodic table. you have a nitrogen in group 15, we have carbon in group 14, and we have sulfur in group 16. If you're in group 16, the same group of the oxygen, so we have 6. So if you sum all, so we have 4 plus 5 plus 6, and I have this charge over here, so we have plus 1. So we have here 10, 15, 16 electrons to distribute around. Don't forget to add the charge. So now I have used 16 minus 2, 4, so I have 12 to distribute around. So if I want to make everybody happy, I can put the nitrogen over here, happy, and I use 12. So when I look at, so just carbon, it's unhappy over here, so I can do this, and I can do this, and we raise the pair of electrons that is now it's shared with carbon, and this is what I have. And don't forget to use the brackets and include the charge over here. So for this one, I will calculate the formal charge for nitrogen. So I have 5 minus 1, 2 bonds, minus 1, 2, 3, 4. So 5 minus 4 minus 2 will be minus 1. And then I put it over here. And the carbon will be 4 minus 4 bonds minus 0 electrons around, so it's 0. So now sulfur will be 6 minus 2 bonds minus 1, 2, 3, 4, so it will be 0. Okay, so let's go to this one over here. I'm going to use another pen just because. So let's go to C, S, N. So I'm going to follow the same steps. So we're going to have this, and I'm going to put my brackets over here, and let's calculate. So I have 4 minus 2 bonds minus 4, so it will be minus 2. Really huge charge over here. Sulfur will be 6 minus 4 minus 0 will be plus 2. And nitrogen will be 5 minus 2 bonds minus 4 will be minus 1. So see that if you add everything together, minus 2 plus 2 plus minus negative 1, the summatory of those formal charge is equal minus 1, which corresponds to this charge over here. So looking to this, between those two, we know this one is better because it has lower formal charge compared for the other one. So let's, and you must ask like, oh, I want to see the nitrogen in the middle. So okay, let's go to the nitrogen in the middle, right? So if you're gonna use this, let's put the nitrogen in the middle, and the carbon has 8, sulfur has 8, everybody has 8. So everybody happy. Oh, my electrons not appearing right over here. So if you go to carbon, formal charge will be 4 minus 2 bonds minus 4 electrons will be, I'm going to talk about carbon, minus 2, right? So I put it over here, minus 2. Nitrogen will be 5 minus 4 minus 0 will be plus 1. So I have a plus 1 over here. And sulfur will be 6 minus 2 minus 4, and it will be 0. So the summatory here, it corresponds to this. So it's okay, but now look at this. I have plus 2 over here, plus 1 over here, negative 2 and plus 1, positive 1 here, and 0 here. So again, the smallest formal charge is over here, so that is the best structure. That's why you use the least electronegative in the middle. So now you know how to construct your structure and how to choose the best structure. Okay, so that's it. That's all.